Hi everybody, and welcome to the exploration at the top of page 39 in the workbook here. We already have a number of shortcut derivatives formulas behind us, and in this video we're going to try to come up with two more to add to our list. Okay, so let's read this together. So they're giving us the graph of the function f of x equals sine of x. That's what we're looking at over here to the right. And on the same set of axes, they'd like us to sketch rough graphs of the derivative and the second derivative. Okay, so this is going to be an opportunity to review a little bit of what we did earlier on in the course, looking at the graph of a function and trying to sketch its derivative. So if we want to sketch the graph of the derivative of f, we might start by asking, are there any places where the derivative is 0? Okay, notice that there are several. Okay, so lots of places where we're getting horizontal tangent lines. And since the slope is 0 at those points, we know that the derivative graph has to be right on the x-axis at those points. Okay, so it gives us a starting point for the derivative graph that we're trying to draw. All right, and now we want to see if we can figure out where the derivative is positive and negative. Okay, and as we're doing this, you'll see me kind of erasing pieces over and over again. Otherwise, this diagram is going to get too cluttered. Okay, so to the left of this first point, where would the derivative graph be? Okay, so along this stretch of the graph, notice that the function is increasing. Okay, that means that the derivative graph has to be above the x-axis, so maybe it looks something like that. Okay, and then what about the next stretch of the graph here? Well, that's going down left to right, so the derivative graph would have to be below the x-axis. Okay, and again, I'm going to try to avoid marking too many things, otherwise it's going to get confusing. All right, and then we come to the next stretch of the graph from here to here. Notice that f is increasing there, so its derivative should be above the x-axis, maybe something like that. Okay, and you get the idea here. Next stretch, f is decreasing, so its derivative is going to be below, and then finally above. Okay, so the blue graph that we just drew, that's our best approximation of f prime. Okay, and now a question for you. Looking at that graph, does that remind you of a graph maybe from a trig class or something like that? Okay, the graph starts up here, and it has the same wave pattern. That kind of looks like the graph of the cosine function. It turns out to be a true statement. And so what we've just discovered is that if we take the derivative of the sine function and draw its graph, what we get is the cosine function. Okay. And now what they'd like us to do is to essentially repeat this experiment again. This time, think of f prime as our starting function, and let's sketch a graph of its derivative. That's going to give us f double prime. All right, so looking at the blue graph, we'll start by noticing that there are some places where the derivative is 0. Okay, and actually I didn't draw this very well, but there actually we get 0 derivatives there and there as well. And so if we plot those points, okay, where we're getting 0 slopes, we would get that. Okay, and then notice that if you look at this first stretch of the blue graph, it's going down, which means that the derivative should be below the x-axis down here. Okay, and then the next stretch of the blue graph is increasing, so its derivative should be positive up here. And you keep doing this, you'll notice that we just kind of keep alternating. Okay, and so that red graph that we just drew is the graph of the derivative of f prime, which would be f double prime. All right, and same question to you. Do you recognize the graph that we're looking at? What does the red graph look like? Well, notice that it's kind of the exact flip of the graph that we started with, sine of x. Okay, if you trace out sine of x, notice that the red graph is just the reflection of that graph through the y-axis. In other words, f double prime is actually equal to the negative sine function. So what we've just figured out then is if you take the derivative of the blue graph, which is cosine of x, you get negative sine of x, just the reflection of the graph that you started with. Okay, So what we have figured out, our conjecture is that if you take the derivative of the sine function, you get the cosine function. And if you take the derivative of the cosine function, you get negative sine. There's two more shortcut formulas to add to our list of shortcut derivative formulas.